Welcome back to the Electrical Lab. You are watching the second video of the Oscilloscope video series. To observe two signals on the screen, we select the dual mode. Since we observe two signals of the same frequency, the trigger source can either be channel 1 or channel 2. To make sure that the zero voltage level is correctly displayed on the x-axis, we place the input selectors of both channels to ground position. If the lines are shifted, we can use the vertical position controller of each channel to bring them back to the horizontal axis. To observe the signals, we place the selector switches to DC input. Now, we adjust the X and Y scales to observe the signals clearly. The peak-to-peak voltages of each signal should be measured using the relevant scales. Channel 1 waveform has 4 divisions peak-to-peak. And its scale is 0.2 volts per division. That means the peak-to-peak voltage is 0.8 volt. Channel 2 waveform has 4.8 divisions peak-to-peak. Here we need to consider the subdivisions as well. One division is divided into 5 subdivisions. The scale is 50 mV per division. That means the peak-to-peak voltage is 0.24 volts. Unlike the vertical scales, horizontal scale is common to both channels. The horizontal length of one cycle is 5 divisions. The scale is 0.2 milliseconds per division. That means the time of one period of the waveform is 1 millisecond. That is equivalent to 1 kHz. As a comparison, we need to find the phase displacement between the two waveforms. First, we need to find the horizontal distance between two similar points of the two waveforms. Conveniently, we can select the zero crossing in the rising stage of both waveforms. The distance is 0.8 divisions. According to the selected scale, it is equal to 0.16 milliseconds. Since we know the distance corresponding to one period, which is equivalent to 360 degrees, the displacement of the two waveforms can be calculated in degrees. The result is 57.6 degrees. In waveform analysis, we need to find whether a waveform is leading or lagging the other waveform. In this application, we can see the peak of channel 2 is on the left hand side of peak of channel 1. That implies the waveform of channel 2 leads the one on channel 1. Similarly, you can say channel 1 lags channel 2. In this video clip, we have learned how to observe two signals using the oscilloscope and how to measure the phase displacement between two waveforms. Please join us with the next video.